Hey everyone, here's a quick video follow-up from last night. So this is using the knowledge and use of assessments data set, which you will get to see a lot in this class. This is my dissertation. Just to start, we were talking about scale use and how do we tell. If we go to descriptives or frequencies, sorry. So up here, I'm in JASP at the time. You can do very similar things in SPSS. This is the explore feature or frequencies under descriptives within SPSS. But what I'm doing is putting in my items and looking over here and saying, okay, here's my scale, in this case, a 4-point scale, and I can quickly go through and look at counts or proportion. So this would be percentages in this example. But counts is really obvious that the scale was used, disagree, strongly disagree to strongly agree across everybody, but we can see strongly disagree and disagree across all of these 4 items were not used very much. This was rationale to expand the scale, so collapsing the 2 disagree categories and adding a 3rd agreement category. So this is a quick way to at least say, how is the scale functioning and being used from a classical test theory stance? Now, when we get into EFA, this is using the use items, so how teachers are using assessments. If you have not seen JASP, I love the way that it does all of this and really helps understand how these things work very quickly. So everything above a 0.4 is pulled. I could change that, but this is the thing. You can see that there's 4 factors. Ignore this column. 4 very clear factors. There's no cross-loading happening. It's all the way down. And then we've got 2 items down here that aren't loading on anything with this data set. Now, I don't know if these 3 factors are what I'm going to say is real, because there's only 2 items. I like factors that have more items, more indicators of the concept. If you have come from SEM with me, we know that 4 makes it a little bit more stable. That's a good rule of thumb, is at least 4, but maybe 2 could work. It's possible. So now I look at my eigenvalues. I can see I have 1 clear factor, and then these last 3 are pretty small. So factor 4 is right at that 1 cutoff. 1.2, 1.5. I'm going to scroll over here and I'm going to look at my proportions. So factor 1 is the largest. It's explaining 32.6% of the overall variance. Factor 2 is explaining about 8%, factor 3, 7%, and factor 4, about 4% of the variance. Here's the other reason why I really, really love JASP. This is my parallel analysis. I don't have to run syntax. I don't have to compare tables. It does it right here all together. So as long as my data is larger than the simulated data from the parallel analysis, that is support that it is real and not due to chance. Remember, parallel analysis is creating a mock data set, running correlations just by chance to see what happens within the data set. So factor 1 is supported, factor 2 is supported, factor 3 is right here, not really clear, factor 4 is down here, not supported as not being due to chance. The problem is, I can't just say, well, these aren't real, so we're just going to retain factors 1 and 2, and I'm going to ignore these 2. Because when I look at the content of these, they actually do make sense together. So factor 1, these items are all about planning a study or planning curriculum and how you use assessments in that process. These 2 items are all about using assessments to give feedback to students on what and how to improve. These 2 items are about data and how do you break down data and do you read disaggregated data. So those are our assessment items. Analysis items within assessment. And then these 2 are about setting goals and communicating goals. It makes sense that these actually do make sense together. So is it a small factor that is supported or is it not? This is where the judgment call starts to come in. So the question that we had last night is, how do these group together? And it's not by person, it's about the item. So how does this item relate to this item, relate to this item, and this one, and this one? And these are grouping together as a packet of variance because they're all highly related. This is grouping together as the next packet of variance, that these are acting and operating differently than these, and all the way down. So I ran a huge correlation table just to start to think about what this might look like. I will provide another thing if you really want to see the math behind the scenes and the matrices and all of that. But generally, let's start and look at these. So we've got the first 6 all grouped together. When we look at this, we've got a 0.6 relationship. That makes sense. 0.3, 0.4, 0.3. 3, 3, 3s, some 2, some smaller ones here, 3s, here we're in 5s, almost a 5, another 5. So we've got all of these are pretty moderate correlations to each other. But then when we get to our analysis items, so 9 and 10, all of a sudden 0.1, 0.1, 0.1, 0.1. Okay, we've got some 2s, and another 1s. So these are much smaller than what we saw up above. So these items are not relating to these items in the same way. Meaning somebody might be positive on I know how to set goals, and maybe they're in the middle on how to analyze data, or maybe they're disagreeing for those items that they know how to do these things. So they're not answering in quite the same way. And so the items are thus operating and correlating to each other in a different way. But when we look at these two items, 9 and 10, correlated to each other, all the way over here, we're at a 0.6. So if we just scan these two things, these are all 0.2s or lower, but these two related to each other is a 0.66. So those two is a very clear pocket of variance that's different and operating differently, relating differently to the other items. Hence, it's popping out as its own factor up here. And that's why we're starting to see that there's this other thing happening within these. Now, that does not mean, that means that across all of these people, that's what we're seeing. We are not saying, oh, English teachers know how to give feedback better, so they're this packet of variance, and the STEM teachers are better at math and analysis, so they're this packet. It's not that. This is everybody all together and how they're responding overall to these items and how these items are holistically related to each other. That's how we're going to start pulling out packets of variance. I hope that makes sense. Let me know if it doesn't, and I will try again.